Hey guys, this is Miss Patton. We're taking notes on 10-2, formulas for circles and regular polygons. Okay, so let's first define a circle, because you guys don't know what one is. It is the locus. Oh, wow. That's not supposed to happen. It is locus of points. So that's like the set of points in a plane that are a fixed distance from the center. Okay, when we talk about circles, we label it like this, and then we write whatever the letter is that we use for the center. So if this is circle A, so that means the center is an A. Then obviously there's a circle around it. Stuff you already know, the radius for this circle would be AB. The diameter has to go through the center, so we'll call that one CD. And then if you have a line that goes from an edge of the circle to another edge of the circle that does not go through the center, it's called a chord. And I'm not sure why my circle just disappeared, so just hang tight while I retrieve it. Okay, we have a circle again. So we'll call this XY, and that would be a chord. Okay, so just quickly reviewing the area of a circle, circumference of a circle formulas, which you probably remember. Area of a circle is pi r squared. Circumference, or distance around the circle, which we also call perimeter of the circle, is 2 pi r. You can also use the formula d times pi, which makes sense because 2 times r is the same as d. Okay, so that was more review. Now we're going to do regular polygons. We've already talked about regular polygons, but remember that they have congruent sides and congruent interior angles. And then another thing about regular polygons that we haven't talked about but seems obvious is that the center is equidistant from all the vertices. Let's draw a pentagon. Give it a center. Let's call the center A. So let's label those distances. It would be the same. Put your hash marks in there. We'll put hash marks on the sides because they're all the same because it's a regular polygon. And then we have this the central angle. And remember the formula for that is 360 degrees divided by the number of sides. And that's going to tell you the central angle for one of the triangles that creates the polygon. And then we have a new line that you've not heard of before called the apothem. And they use the letter lowercase a for apothem, and is the distance from the center to the side. And it always sits at a perpendicular, so if you want to write a little perpendicular symbol, that would be good. So in this picture, let's create a B. Draw a line from A to B, and notice you're creating a right triangle when you make your apothem. So that would make AB equal to A, which is the apothem. Okay, and then we have a formula for the area of regular polygons. And that would be A equals, so area equals 1/2 times the apothem times the perimeter. And if you want to know where that formula came from, you should ask me some other time when we've got about an hour to spare. Okay, we'll do one example and then we're done. Find the area of a regular pentagon. I always use pentagons because they're the only ones I can draw. With a side length of 8 inches. Okay, so let's draw a picture first of all so I can clarify why I do what I do. So pentagon, 5 sides. I'm not going to draw all 5 of the central angles in because I really only want one to deal with. And so I know that my side lengths are 8. And I need 2 things. I need the apothem length and I need the perimeter. So perimeter is easy. It's a pentagon, so 5 sides times 8. So our perimeter is 40 inches. So that part's easy. Your apothem, on the other hand, is not so easy. So we need to find the apothem length. And so apothem is going to be a 90 degree to the side, right? So if this is 8, it's going to, because it's regular, so everything is symmetrical, it's going to break these off into 4s. And then you're going to use your rules of either special right triangles or figure out the central angle and divide it in 2, and that'll tell you what this angle is here. So let's find the central angle of this. So that's the next thing that we need before we can find the apothem length. So this has 8 sides, so it'd be 360 divided by 8, which is going to be 72 degrees. And so the little angle in my right triangle is 72 divided by 2, because it's going to split it perfectly in half, so that's 36. So this little guy right here is 36. And then you're going to either use sine, cosine, or tangent depending on which pieces of information you have. So right now you know the opposite side and you want the adjacent because that's the apothem. So you're going to use tangent. So you're going to say the tangent of 36 is equal to 4 over your apothem. And put this over 1. So this is basically 4 divided by the tangent of 36. So your A is equal to 4 divided by tan of 36, which if you use your calculator and make sure it's in degree mode, you would get 5.51. Now we can plug it into our, oh, that would go up here. Now we can find the area of our figure. So area is equal to 1/2 times 5.51 times the perimeter, which we know is 40. And again, we are estimating, so don't forget your squiggly equal sign, and you should get 110.1 inches squared. Alrighty, that's all you need. Good luck. Talk to you guys later.